Good day, everybody. How are you all? This is Dr. Nandi. Today we are going to talk about the central limit theorem and application. Okay, so I'll share my computer screen with you. Says an unknown distribution has a mean of 90 and standard deviation of 15. A sample of size 80 is drawn from this population. Find the probability that the sum of 80 values is greater than 7,500. Find the sum of, that's part A. Part B, find the sum of 80 values, that is 1.5 standard deviation above the mean. So we will first do part A. In the cover of the keys. We can apply central limit theorem in this case because sample size is greater than 30. So our sample size n is equal to 80. So, so if we draw a sample of size 80 from an unknown distribution population, the distribution of means will be a normal distribution. Normal means bell-shaped distribution. Bell-shaped distribution. And according to CLT, according to central limit theorem, let me use that. According to central limit theorem, mean of the distribution of the means, okay, is equal to mu x bar. This is equal to the mean of the distribution of means. So according to mu x bar is equal to mu and sigma x bar, which is standard deviation of the sampling distribution. Distribution of means is called sampling distribution, by the way. So this is called sampling distribution, which is the probability distribution of means. Sampling distribution, standard deviation of sampling distribution. Okay, that's sigma x bar. And sigma x bar, according to the central limit theorem, sigma x bar is sigma, that is a standard deviation of the population divided by square root of the, where mu is the mean of the population, and sigma is equal to standard deviation of the population. Deviation of the population. So in our case, mu x bar is equal to mu is equal to 90. And sigma x bar is equal to sigma divided by square root of n, which is sigma is 15. You will do this way in the calculator, then divided by second button, and then x square button, which is in the first column halfway down, gives you the square root. Inside the square root, type in the sample size and enter. Okay, so let's do it that way in our calculator. I have 15 divided by second button, then x square button, gives me the square root under the square root, sample size of 80, and the answer is 1.677. So sigma x bar is equal to 1.677. Okay, and mu is 90, I've already established. So let me create some space for myself. And I want to move this. Okay. Maybe attach below. Okay. So now in part A, sum of 80 numbers is greater than 7500, is greater than 7500. So average of 80 numbers is then 80 numbers is 7500 divided by 80. Okay, so 7500 divided by 80 is equal to 93.75. So if I create some more space, okay, and I will draw the diagram then. So this is the diagram. This is the mu x bar at the center is equal to 90. Sigma x bar is equal to 1.677. And we have located the mean greater than 93. So here, this one is 93.75 on the horizontal axis, and we want to find this area greater than 96.75. Okay, so we want to find out the probability of x bar greater than 93.75. So that is equal to, we go to the calculator, second key, then verse key, then go to normal CDF, okay, and enter. So second key, oops, I don't know it. So second key, then verse key, then I go to normal CDF. My lower, in this case, lower is, I'm starting from 93.75. My upper, in this case, is 1, then second key, then comma key, which will give me the small capital E, then I will type 99. It means 1 followed by 99 zeros. So my lower is 93.75. My upper is 1, then second button, then comma button on top of 7. That gives me the E, then 99. My mu is 90. So type in 90 for the mean. And my sigma Type in is 1.677. 1.677. And then I go to pest. And as you know by now, pest means I have to hit enter button twice. Enter and enter. Enter once, then enter again. And the answer is, so again, I have to move the screen. Move the board a little bit up. So, probability. So we have to find probability of X bar greater than 93.75, and that is equal to 0.0127. So this is the answer for part A. Now, part B. Okay, if I bring it down a little bit, let me see if I can bring it down a little bit, read the problem, part B at least. Find the sum of 80 values, that is 1.5 standard deviation above the mean. Okay, so now if I move it a little bit, okay. So let me draw the picture now. So part B, okay. My center mu is X bar is 90. My sigma X bar is equal to 1.677. And I want the value of X bar, this unknown X bar, such that to find X bar, such that it is 1.5 standard deviation above the mean. Deviation above the mean. Above the mean. What does it mean? It means the z-score, which is given by x minus mu divided by sigma. The z-score positive 1.5. Okay, and I know my mu is equal to 90. My sigma is equal to 1.677. So z-score is 1.5 is equal to x minus 90 divided by 1.677. Now, to solve this equation, we will multiply by 1.677 on both sides, so that 1.677 in the denominator on the right cancels, and we will have 1.677 times 1.5 on the left is equal to x minus 90. This happens because I multiply by 1.677 on the right side, where 1.677 on the numerator and denominator cancel, and on the left side I have 1.677 times 1.5. So let's do that. 1.677 times 1.5 is equal to, that is equal to 2.516, you might say, and that is equal to x minus 90. Then you add 90 on both sides, so x itself is equal to 92.516. So this is the mean of 80 numbers, which is 1.5 standard deviation above the mean. So mean of 80 numbers, if I write here, mean of 80 numbers, which is 1.5 Standard deviation above the mean is 92.516. Okay, so you know the definition of the mean, mu. So mu is equal to sum of the numbers divided by number of numbers. So I have the mean as 92.516. Okay, I want to find the sum of the numbers, and my number count is 80. So I multiply by 80 on both sides to get the sum of the numbers. This is the sum of the 80 numbers, which we are interested to find out in part B. And that is equal to 80 times 92.516, which is 7,401.28. So this is the answer to part B of this problem. Okay, so I will stop here today. If you have any question, comment, write me a note. I'll get back to you as soon as possible. And if you like this video, please give me a thumbs up. I really appreciate that. And if you like this video, please share this with your friends. You and your friends, please subscribe to my channel by hitting the red subscribe button at the bottom right corner. I will see you next time with another interesting problem, interesting solution. Thanks for watching. Take care. Have a nice day. See you next time.